Hey there, Mr. Weaver here, and this is Geometry Lesson 7, Rigid Transformations and Congruence. After this lesson, you need to be able to move or describe how a shape moves in a translation. You need to be able to draw or find the mirror line of a reflection, and you need to be able to draw or find the center of rotation in a rotation. You'll know you're successful after this lesson if you can translate a shape and or describe how it moves, reflect a shape and or find the line of reflection, and rotate a shape and or find the center of rotation. First, let's start off with a word you're going to see a lot in this lesson. That word is transformation. So here, a transformation is the change in the size or the orientation, so the positioning of a figure. In this lesson, we are going to be talking about rigid transformations. So these ones actually don't change the size, okay? They don't change the angles, they don't change the lengths. All it's really going to do is change the orientation. So how is it positioned? The shape from the beginning to the end is going to look the same, just positioned slightly different. The three types of rigid transformations that we're going to be looking at are translations, reflections, and rotations. In this lesson, there are also two other words that we're going to be using. There's preimage and image. So the preimage is the shape before a transformation. So here I am before my transformation. You can see here that F, my feet, are positioned in the bottom left, and H, my head, is positioned in the upper right. The image is then the shape after a transformation. Now my image is the same as it was before, except positioned slightly different. So now my feet are in the top left and my head is in the bottom right. Notice in the image, it has a little apostrophe after the letter. That is called prime. So in the images, the afters, you would actually read that as F prime or H prime. So without the apostrophe is the before. With the apostrophe, your primes are your after. Before we look at how these things actually work, let's go through what each of these means. So a translation is a movement or slide of a figure along a straight line. So it might be straight left and right, might be straight up and down, or it could be straight diagonal, but it's going to move along a straight line. A reflection is a transformation that flips a figure across a line. The line that it's flipped over is called the line of reflection or a mirror line. Third, we have rotation. So that is where the figure is turned around a specific point. And then that point where the figure is turned around, that is called the center of rotation. In all three of these, there is one thing that they have in common, and that is that they are congruent. That means from the preimage to the image, it has the same size and shape. So it doesn't magically get larger or smaller. It doesn't stretch, get wider, taller. It's the same shape as it was from the preimage to the image and the same size. They just might be moved, flipped, or turned. Now let's get into what some of these look like as examples. So let's start with translations or slides. First example, translate the shape up 4 and right 3 units. So in this situation, we are just moving the shape up 4 and to the right 3. So every point on this shape moves the same. They're all going to move up 4 and to the right 3. Let's say that top corner of our L shape there was point A. We're going to move that up 4 and to the right 3, as shown by the arrows. That would be where A prime is located. Remember, the primes are where your image is. So each point is going to be moved up 4 and over 3. I could keep going with the same pattern, for every corner here. So that inner corner of the L would go up 4 over 3. Once you've drawn enough points, you can see where that new moved image will be. So every point on the pre-image was moved up 4 to the right 3, and then we could create our image from where that's located. Now it's your turn. Pause the video and translate the pre-image down 2 and left 5 units. Let's check. Your shape should be about this location. Every point on the pre-image is shifted down 2 and to the left 5, so your shape should be in that space. In some situations, you're going to be given both the pre-image and the image. Remember, the pre-image is the one that's the regular letter, the image is the one that has the prime symbol, so that's your after. Here we're asked to describe how the shape was translated. So here it's especially important to think about where we're starting and where we are ending. So we are starting with our pre-image, which is our regular A, and ending with our image, which is A prime. So if I look at where A is and where A prime is, how would I move one shape to the other? Here I would need to go down 4 and to the right 2. Every point on that shape was moved the same. We can double check. Other points were also moved down 4 to the right 2 to move from our pre-image to our image. So that would be describing how the shape was translated. I would say it went down 4 and to the right 2. Now, be careful that you choose the correct shape, your pre-image of where you start, because if you accidentally start with the wrong shape, your description will be backwards. Now it's your turn again. Pause the video. How was the shape translated? Here, the pre-image is the one that is colored in. Let's check. Going from the pre-image to the image, the colored in to the transparent one, you had to go up 3 and to the right 8 spaces. Now let's look at the next thing with reflections or flips. So here we want to reflect the shape over the y-axis. Please be careful. If it's over the y-axis, most times it will indicate on the axis which one it is. But remember, y is up and down, so you're actually going to be flipping it left to right. If it says over the x-axis, then you're going to be flipping it down or up. Here we want to reflect over the y-axis. So I've labeled A and B in my pre-image. For reflections, each point on the shape is the same distance from the line of reflection, but on the opposite side. So our line of reflection in this case is the y-axis. So if I start with point A, that is 3 units away from the y-axis. That means on the opposite side, A prime is going to be 3 units away. So I'm going to put a point there so I can begin to draw my shape. Not dealing with point B, but the bottom shape, that is 5 units away on the left. So the bottom corner would be 5 units away on the right. I would put another point. I'm going to keep doing this until I have all of my points that form my shape. So if you notice, there are 2 points that are actually on the right side. Because they're 2 away on the right side, when I'm drawing it, I would need to make it 2 away on the left side. Once we've connected enough points, we can draw our image. And here you can see that B prime is now on the opposite side of A prime compared to where B is with A. They are reflected. Everything is flipped. Now it's your turn. Pause the video. This time, reflect your shape over the x-axis. Let's check. So you should have actually flipped yours down. The x-axis is the horizontal axis. The bottom side of our pre-image is 1 away. So our image would also be 1 away on the other side. Everything is equal distance, but on the opposite side. Now that we know how to create reflections, we also need to be able to determine what the line of reflection is. So here I have my pre-image and my image. If I'm trying to figure out the line of reflection, since reflections are the same distance away on both sides, the line of reflection is going to be exactly between the two. So one strategy you can use, if you figure out how far apart the same point is from both the pre-image and the image, then you can figure out halfway, which would be your line. So that corner of the L there, those are 8 apart, which means that our line of reflection would be halfway between those, or 4 away. If we chose other points, such as those two, they are 4 apart, so they would both be 2 away from our line of reflection. So halfway between those, our line of reflection must be there. Now, to identify what line that is, if it's a horizontal line, it's going to be y equals and then whatever number that it goes through. So in this case, it's y equals -1. If it's a vertical line, then it's going to be x equals whatever number that it went through. If you're confused on which, look at the axis that it crossed. So here it crossed the y-axis at -1, so y equals -1. Pause the video, see if you can figure out what the line of reflection is for your pre-image and image. Again, the pre-image is the one that is colored in. Let's check. You should have found that the line of reflection was x equals 1. It is that vertical line right there where everything is an equal distance on both sides. Remember, if you are having trouble, if it's x or y equals, it went through the x-axis, and how many over did it go? 1. So x equals 1. Sometimes your reflection might be diagonal. If you come across a situation like this, just know that your line's going to be diagonal. So again, identify points on your pre-image and your image halfway between. So here, I would need to be halfway between those 2 points, halfway between those two. My line would look something like this. It would also be halfway between those two if you wanted to choose other to check. Again, it's halfway between all corresponding points from the pre-image to the image. Now, to come up with the equation of the line, I'm going to think back to topic 2, start with my y-intercept. It crosses at 0, and then my slope, it's going up 1 over 1 each time. So y equals 1x plus 0, which we could simplify to just y equals x. So the line of reflection was y equals x. Now it's your turn. Pause the video, see if you can figure out what this diagonal line of reflection is. Let's check. The line of reflection is y equals -x. It is being reflected across itself. It's kind of hard to see, but the line of reflection goes through right there. The third type of rigid transformation are rotations, or your turns. These are the most complicated and honestly probably the more difficult of the three. So when we're talking rotations, you're going to come across 2 words that are dealing with a clock. So here we have an old analog clock. When we're rotating, we're going to see 2 words, clockwise and counterclockwise. So clockwise means that it would follow the numbers in order on a clock. Counterclockwise, or you might happen to see it as anti-clockwise. That just means it's going backwards. So when you're rotating, it's really important to pay attention to which direction the shape is rotating. Also with rotations, you are going to be given a degree that it's rotated. So if it's rotated 90 degrees, that is 1/4 of a turn. So if it was at 12, 1/4 of a turn would now be at 3. 180 degrees is half of a turn. So if it was facing 12, now it's facing 6. It completely turned around. If you are familiar with skating terms, doing a 180 means you rotate and now are facing the other direction. 270 degrees would mean you started at 12, you rotated 3/4 of the way around, and now maybe you're facing 9. One thing I do want to point out is that a 270 degree turn clockwise is the same as a 90 degree turn counterclockwise. So if you are given a 270 degree rotation, you can always think of it as a 90 degree rotation in the opposite direction. Let's start by rotating our shape. So here it says rotate the shape 90 degrees clockwise around the point 3, -2. For a rotation, every point on the shape is going to turn and move around the point by the same degree. So here, around that point, 3, -2, everything is going to shift 90 degrees. So here's how to do this. You're going to want to connect each point on the shape to that dot. Once you've connected, you're going to find our slope. So here it went down 3/1. Just count. A 90 degree turn is going to make it perpendicular. Well, if you remember back to topic 4, perpendicular had an opposite reciprocal slope. So you're going to flip it and make it the opposite sign. And then you're going to go from that point. So now up 1/3. You can see those two line segments together would make a right angle. I'm going to put my point there. So there's my first one. Then I'm going to keep doing this again and again. So now I'm going to connect that bottom left corner. It was down 3/8 from the center of rotation, up 8/3, and plot my dot. Now I'm going to go from where point A is. So here I had to go down 7/8. So now I'm going to go up 8/7. Plot my dot. That is where A prime is going to be located. You can see we're starting to form our L shape that is rotated. If I continued going with our other points, I could continue my L, and it would look something like that. So not only is that shape turned 90 degrees, but it was also around that point. Now it's your turn. Pause the video, see if you can rotate your shape 90 degrees counterclockwise around the origin. Remember, the origin is point 0, 0. Be careful, work slow, see if you can figure it out. Let's check. You should have found that your shape actually looks like this. So it's kind of overlapping. Origin is 0, 0. If you look, that part of the L is now there. This time we had to go opposite direction, so we are kind of rotating it to the left. If we choose other points, also rotating 90 degrees to the left, counterclockwise. Next, we are going to look at finding the center of rotation. So when finding the center of rotation, the first thing that I'm going to do is just kind of look at the shape and see if I can figure out at least how many degrees it was rotated and in what direction. So our pre-image here is the one that is colored in. I can see that it was turned to the right, so clockwise, and it looks like it did 1/4 of a turn, so 90 degrees. So this would be 90 degrees clockwise. Now, based on the bottom of the L's and the fact that it rotated, I'm going to predict that it's rotating around somewhere in this area, maybe around like 5, 2, 4, 2, somewhere in that area. Now we're going to kind of use what we did to draw, but thinking backwards. So for this, it's almost going to be a little bit of guess and check until you figure it out. To start, I know those 2 points are the same point. They're the corresponding points from my pre-image to my image. So I have to go 90 degrees clockwise. So one strategy that I'm going to have you try to use is the corner of a piece of paper or a sticky note. So here is my digital sticky note. I know that it was 90 degrees. So if I had the point right there, that is a 90-degree turn. I was able to follow the corner of the sticky note and have it go through both of those points. So we're good so far. But remember, every point has to go through that center and also be 90 degrees. If I were to rotate that sticky note to keep it at 90 degrees, notice it would go through the corner of our image, but it doesn't go through that same corner of our pre-image. So the point that I guessed at 7.3, that is not the correct center of rotation, because when I turned my sticky note, it didn't go through the 2 points again. So let's choose a new point. So now I'm going to take my sticky note and kind of figure out another point that went through the 2 dots that I started with. So this time I'm going to guess 5, 1. Now I got to check other points. So this time, does it go through that top corner? Yes, it went through the same corner on both shapes. So I know that it went through those original 2 points, and it's now going through the top corner. Because it went through 2, I'm probably pretty safe to say that that's the center of rotation. So this point here is in fact the center of rotation. Say I were to check this corner down here and this corner here. They are the same distance away, 3 and 3, and it's still a right angle. So that would be my center of rotation. So here my center is at 5, 1. Now it's your turn. Pause the video and find the center of rotation for your pre-image and your image. Let's check. You should have found that your center was at 7, 2. If you were to take the corner of a sticky note and place it at that center, it would go through the corresponding points on both the image and the pre-image. This isn't in your notes, but if you come across a 180-degree rotation, it doesn't matter if it's counterclockwise or clockwise, they're both going to end you in the same place. So here's a strategy if you have rotations of 180 degrees. It's not nearly as complicated as our 90-degree one. Find the corresponding points from your pre-image to your image. So here, those 2 connected. I drew a line to connect them. Now I'm going to choose another point on both the pre-image and the image that correspond. So there I have a different corner of my L. For a 180 degrees, where those 2 lines intersect, that is your center. So here the center of rotation is 0, -1. If you come across 180 degrees, it's as simple as that. Connect your corresponding points, find where they cross. They should all cross at the exact same point, that center of rotation. In this lesson, we learned about transformations, or specifically rigid transformations, where we are just changing the orientation of the shape. There were 3 that we learned about: translations or slides, where you're just moving that shape from one place to another. There were reflections, where you are flipping it over a mirror line and everything is just backwards. And then we learned about rotations, where we're turning the shape around a specific point. One key thing to remember with these rigid transformations is that the image is congruent to the pre-image. So nothing about the shape changed. The lengths were the same, the size was the same, the angles of the shape were the same. Nothing about the shape changed except for how it was positioned. That's very important to remember and the key to rigid transformations. So after this lesson, do you now know how to translate shapes or describe how they move, reflect a shape and or find that line of reflection, that halfway between, and can you rotate a shape and or find the center of rotation? If you're not sure about those things, go back and look at the specific examples to help you understand the concept further. And that's the end of lesson 7 on rigid transformations.